going to create a console application that simulates a shopping cart, allowing you to add items to it and then sort those items in different ways. Then I will demonstrate the queue and stack collections just to show how they work. First, we need to create an item class. It's going to have two properties, title and price. Price is going to be a double. So pretty simple. From the item class, I'm going to derive two types of classes that will actually work with the book and the CD classes. While we're creating the application, we'll be able to add either the book or the CD class to an array and then work with them in the same way because they're derived from the same base class. Both of these are going to inherit from the item class. I'm going to add one additional attribute. For the books, I'll add the ISBN, which is just a number that uniquely identifies a book. And I will create a constructor. This constructor is simply going to define all the properties of the object. Now I'm going to create the CD class, and I'll jump through this so you don't have to wait for me to type. So there's a CD class. Now we're ready to actually work with it. First thing I want to do is to create an array list that allows us to store a combination of books and CDs. Then we will iterate through that array list to display them all to the console. I will call the array list items. And though you wouldn't do this in a production world, I'm simply going to manually type in descriptions for the different items and add them to the array. I use the Windows Vista Resource Kit as the first book. That's a book I worked on. And if you can't tell, I am copying the ISBN. I do not have that memorized. And of course the new Windows 7 Resource Kit. Now I'll add two CDs to demonstrate that you can work with different types of objects so long as they are derived from the same class. Really, you can add anything to an array list, but if you're going to process them in any meaningful way, it helps to have common properties, and the best way to do that is to derive them from the same base class. So those items are added now. I need to create a subroutine that will list all the items to the console. I'll call that show shopping cart. And I will accept the array list as an argument. Simply going to create a for each loop that iterates through each item and displays it to the console using the standard toString implementation. And now I need to create the toString implementation with an item. I'm going to use the overrides keyword. That should do it. Now, from within the main method, I need to call show shopping cart, passing it the items array, and I'm going to call console.readKey just so that the console doesn't disappear. Now I'll run it. See, I overlooked a couple of parens there. There we go, one more time. You can see it displayed the items in the items array in the order in which I put them in. Now it's common to want to sort them in different ways. For example, you might want to sort them by the title or by the price. First we'll handle tackling sorting by the title. To create a default sorter, you want to implement the iComparable interface. To do that, we'll add implements iComparable here. And then we will implement the compare_to function. All the compare function wants is to know which of two items should come first in the sequence. So it's going to pass us an instance of the other object. In other words, this is running within an instance of one of our objects. It's going to pass us as the object parameter the object that we need to compare our own instance to. We then need to return the one that comes first in the sequence. It's actually really easy. All I'm going to do is I'm going to call the base class's compare_to method. I want to sort it by title by default, so I'm going to refer to the title property and call the compare_to method. And then I'm going to pass it the object that it sent me cast properly. Now I need to call the items.sort method in the main routine to actually perform the sort. I'm not going to pass any parameters because I just want to perform a default sort. So let's run this and see if it sorts it properly. You can see it did indeed sort it by title. Contoso, Fabricom, Windows 7, then Windows Vista. Now what if you wanted to sort it by price instead? Well, you can only have the one default sort order. There are a couple of different ways that you might go about sorting in different ways, but I think the most straightforward is to create a custom iComparer implementation. Now, iComparable was an interface that we derived our class from. iComparer is actually a class in and of itself. I'll call it sort item by price. And we'll implement the iComparer interface. You can see Visual Basic creates a basic implementation for me here. All I'm going to do now is to cast the two items to their correct classes because they're both passed to me as base objects. And then I will call the base compare_to method and allow the double dot compare_to method to actually sort it out because the .NET Framework developers have already done that work for me. So here you can see I'm going to call upon the compare_to method of the price property for the first object and then simply pass it the second item. We'll run this again. You can see it's sorted in the same order because I didn't actually create an instance of the sort items by price class yet. Call this instance price sort and iCompare. So you can see I'm creating an instance of the sort item by price class. Now to the items.sort method I will pass my instance. Run this one more time, and you can see the ArrayList.sort method used my iCompare instance to compare each of the objects in the array to determine the sort order based on that instance of sort item by price, sorting them by the price attribute from least to greatest. So the smallest price started the list and the larger price ended the list. That's a pretty thorough demonstration of the ArrayList class. There are a couple other collections that are useful. The first of those is queue. Queue is a first in, first out type collection. You would use it for example, customers waiting in line. The first person who shows up should be the first person served. You don't generally sort queues. Instead, you simply add items to them, you enqueue them, or you remove items from the array, you dequeue them. I'm simply going to replace the ArrayList instance here with an instance of queue. Again, you don't call the add method, you call the enqueue method. You no longer need to sort it because you don't generally sort queues. And we're going to need to update the show shopping cart method to work with a queue instead. You shouldn't iterate through a queue with a for each loop. Instead, what you're going to do is to dequeue each of the methods in sequence. So to do that, I'll create a while loop that continues as long as there's at least one item in the queue. Notice that for every item I have to cast it to the correct type because queue takes an object and it returns an object. I can't do what I need to do with an object, however, and that requires casting. Later you'll learn how to use generics, which allow you to use classes like queue and stack in a strongly typed way. So I'll run this now, and what we should see is the items displayed in exactly the order that I added them in. That's what we expect because it's a first in, first out type collection. You'll see a different behavior from the stack collection. If you're a developer who's done low-level work, then you'll probably be familiar with the way that stacks work. Stacks work in a first in, last out configuration. So it's common to use in the development environment because of the way that methods pass arguments back to the calling method. So if method A calls method B and then method B calls method C, the operating system needs to know where to return execution to when method C ends. It goes to the last caller, not the first caller. So after method C ends, execution returns to method B, and after B ends, execution returns to method A. Last in, first out. I'll change this to a stack, and instead of calling enqueue, you enqueue things on a queue and you push them onto a stack. You need to update the show shopping cart implementation. Instead of calling dequeue, you call pop. You pop things off of a stack. If you wanted to read an item from the stack without removing it from the stack, you would call peek. Now you notice that the items are in the exact reverse order that I added them to the array.